Hello everybody, this is our week 7 lab. I'm Professor Halsey, and here we're going to look at the Configure and Verify IP Services module. It provides you with the instructions and the Cisco hardware to develop hands-on skills in configuring Dynamic Host Configuration Protocol, or DHCP, services, including using an iOS router as both a server and a client, plus synchronizing time across the network using NTP and syslog logging services. This module includes the following exercises. 1, we're going to configure and verify DHCP using Cisco iOS. We're going to configure time synchronization using NTP, and then we'll set up and configure the syslog. Okay, here's exercise 1, configure and verify DHCP using Cisco iOS. In this exercise, we're going to configure a Cisco router to act as a DHCP server within the lab environment. As you've learned in your course, DHCP is a service that enables hosts to get an IP address dynamically without you having to manually configure it. This was nice because when I was first getting out of college, I was the DHCP server. I had to go around and set the IP addresses on toggle switches on the NIC card. Kept a notebook of all the IP addresses and which unit they were assigned to. So I was the DHCP server, so this is a nice service. This is particularly useful where you have hundreds of PCs and laptops and other devices that don't require static addresses in your network. Use your study material or your favorite search engine to find the following topic. There's our diagram. I don't want to skip over that because it's important. We're using the server here, and it's going to be a PC as well. NY-Access 1, Core 1, Edge 1, and WAN 1. Okay, and they're listing our network address, our gateway, our DNS server address, our domain name, lease time, and excluded addresses. In this first example, you're enable DHCP and configure an address scope on NY-Edge 1 such that NY-WAN 1 will be able to retrieve an IP address automatically. We use the subnet that is commonly used within the lab, which is 192.168.16.0 with /24, meaning 8 bits are used for subnetting. The following task will need to be completed to configure DHCP. We have to create an address pool, specify the IP configuration for the pool, specify any domain-related settings for the pool, and specify additional options that are required. And then specify any IP address exclusions that are required. All right, so on NY-Edge 1, make sure you're on Edge 1. And we'll configure terminal and do IP DHCP pool. And its name will be lab pool. Okay, then we're going to come on down and do the next step, which is specifying the address range and mask length for the pool. So we're going to tell it our network is 192.168.16.0 with a /24. Okay, I didn't get the conflict error that they got. Okay, next we'll exclude an address or range of addresses. Exit the DHCP configuration back to global and use the IP DHCP exclude address command to exclude those addresses. In this example, we'll reserve 1 through 15 because that's what they told us in the diagram. These are low and high address options for the command. Oh, there it came. Alright, so we'll exit out of configuration and do an IP DHCP excluded dash address, and I guess first they want us to see the options. So we'll exclude 192.168.16.1 to 192.168.16.15. In the above example, I've used the question mark so you can see two options when configuring the excluded range. You can do a low to a high, or do a VRF name for an excluded range. So if you have a VFR file set up with an excluded range listed, then you can use that as well. Configure, so we're on to step 4, configuring some optional settings, including the DNS server, a domain name, the default gateway, and finally the lease length. Okay, so we'll set up IP DHCP pool lab pool, and we want DNS dash server 192.168.16.10 with the domain dash name of practicelabs.com. And I realized there I spelled practice wrong, so PR. Alright, and then we'll set the default dash router to 192.168.16.1, and we'll set a lease for 7. Okay, to test the configuration, we want to use NYWAN1 as a client to get an address on G00. This is very straightforward, so we'll come over here, enter, enable, conft, and we want to go to interface G00 and do IP address DHCP, no shut. The no shut command brings the interface up. Now confirm your DHCP scope has worked using the relevant show interface command. Notice you will also see a log message on the console once the router receives an address. Because of STP, Spanning Tree Protocol, it will take a few seconds for the interface to be able to communicate on the network and hence receive an address from NY-Edge1. Okay. So on NYWAN1, we're gonna, no, because I need it to come back. There it goes. Okay, so it has given me my DHCP address. All right, now if we want to verify that, we'll do the show IP interface brief. Oh, I gotta come out of the interface and out of configuration and do a show IP interface brief. Okay, so here we can see G00, 192, 168, 16, 16. So it skipped 1 to 15 and picked up the first available address, which was 16. So yes, we did good there. We did all that. To verify the address assignment from the DHCP server perspective, you can use the privilege mode command show IP DHCP binding. So we're coming back to NY Edge 1 and do a show IP whoops, nope. We got to come out of here and exit out of there, and now we can do a show the IP DHCP binding, and it shows us here that 16 was issued to this MAC address. We could go verify that MAC address. Alright, as a final test, you can set the lab NIC on the server to use DHCP. Ensure you configure the correct network card, otherwise you will lose access to the PC and you will need to reset it. Make sure NY Access and NY Core 1 are powered on, otherwise there will be no layer 2 connectivity. So we need to verify Core 1 is on and NY Access 1 is on. Set the lab NIC to receive configuration using DHCP. So once you click OK, check the IP configuration using the command prompt ipconfig-all. Alright, so we'll come down to the PC and I've got to turn it on. Okay, so we're going to go to Start and Control Panel. At least this is how I know how to get there. Then I want to go into Network and Sharing and change adapter settings. Here's my lab NIC. Then I'm going to Properties, TCP IPv4, Properties, and Obtain Automatically. Okay. Once you click OK, check the IP configuration using ipconfig-all. Let me get all this closed out and then I'll be able to see it. We need to go to the command prompt and ipconfig /all. Now come back up and look for lab NIC. Where's he at? And there's his IP address. At 16 was being used on WAN 1. This one picked 17. So we have verified that it will pull an address from the DHCP pool as well. Okay, so we'll close that one out, and they want me to come back to NY Edge 1. And on NY-1, do a show IP DHCP conflict. If you didn't receive a conflict message, your conflict list will be empty, which is good. To release an IP address, like say from WAN1, we can go in and clear IP DHCP binding to 192.168.16.16. Okay, view the bindings after you clear it. And do show IP DHCP binding. And you'll see it knocked 16 off the list. All right, for exercise 2, we're going to be configuring time synchronization using NTP. In this exercise, we'll configure NTP on a Cisco device, both a router and a switch. NTP is very important in many networks as it serves as a method to keep accurate time on all of your devices. This can help with transactions that occur that need timestamps, tying up log events across different devices, and troubleshooting events, plus many other reasons. You may want to know when, who, was, when, who, when, where, and was, why. Use your course material or your favorite search engine to find more about Cisco configuring NTP, but we're about to do it. NY-1 is configured as an NTP server in the lab. First, let's change the time on this device so we can see NTP's impact once we configure it. So on NY-1, we're going to clock set 09:00:00 June 01/2013. And you'll see the system clock has been updated with the date and time that we just entered. To configure a router as an NTP client, you'll simply tell the router where to get time from using the NTP command. So we'll configure WAN1 to get its time from NY-1. But first we want to look at the time on WAN1, so we'll do show clock. It should have the current date and time. Actually, that's wrong. It says December 20th, 1903. I'm not sure what date and time they're on. If I'm reading that right, something's wrong. Anyway, it's wrong. All right, now we're going to go configure terminal and set the NTP, enable, then configure terminal. And we're going to set NTP server to 192.168.16.1. To view if the router is using Edge 1 as a time source, we'll first tell it to show NTP associations. And we should see here our address for our server. Okay, so we're going to then do show clock. And we can see, whoops, it did not set to my, it did not set to my updated address. Okay, let me go back to NY-Edge1. Reset. Try it one more time. Okay, so NY-WAN1. Show clock. Oh, now it's updated. Guess it took it a minute to connect. And by the time I looked and came back, it connected. Okay, so we see the clock is adjusted accordingly. So I was just reading. Sometimes it does not always sync. In other words, you don't get an asterisk next to the configured NTP server. Try two things. Remove the configuration on NY-Edge1 and reapply, and then remove and reapply the NTP command on WAN1. So that's pretty much what I was about to do. Just do it all over again, but it worked, so I'm good with that. Yeah, so that's repeat the process. Yep. All right, now we're on to exercise 3, configuring syslog. On the server, there's a piece of software called TFTPD32, which is free and open source TFTP server. It's also a syslog server if you want to download the outside of the lab. Use a search engine to search for TFTPD32. You'll use this software throughout the exercise as it supports syslog. Okay, before configuring syslog, change plabs back to its original IP configuration. Okay, I'm glad they got it listed there because I didn't write it down, which is a no-no. You should write it down. um, Network and sharing, and I'm going to go change my adapter settings for lab NIC. Properties, TCP/IP-v4 properties, and we want to use the following: 192.168.16.10, and subnet mask 255.255.0, gateway 192.168.16.1. Okay, the DNS server list is empty. Okay, ignore the error you get. Ensure you complete this step before proceeding. That means double check it, TCP/IP properties, and it's all listed there and it's correct, so we're good. And close. And I'm going to close these out, and on PLab, on the PC, I want to run the TFTP D32. Okay, change the server interface settings so it's listening on 192.168.16.10, and it was. Click on the syslog server tab, So you can see any syslog server messages once you have configured syslog on one of the devices. Okay, now minimize this, don't close it out. We can go to NY Access 1 and enable Comp-T, and we're going to int VLAN 1 and set the IP address to 192.168.16.7 space 255, 255, 255, 0, and no shut. All right, to configure sending the syslog messages to a syslog server, this is what we did in the lab the other day. So we're still in configuration mode. I'll come out of the interface and set logging host to 192.168.16.10. And I've been doing so well with my spelling today. Exit. Confirm. So we'll go to Core 1, and on Core 1, enable, Comp-T, go to NFA 1/0/22 and tell it to shut down. Go back to NY Access 1, and you can see the interface FA024 changed state to down. So all the syslog messages go to the syslog server. Now observe the output on the PC. So if I come down to the PC, and there we go, we can see that exact message here. Okay, so we've configured a Cisco device to send log messages to a syslog server. So we set up a DHCP server and had a couple of devices, few devices pull IP addresses from it. We configured NTP on the router so that it received time from the network clock. And we set up a Cisco switch to send all its log messages to the Cisco server. Thank you. Hope you enjoyed our last lab.